Assalamualaikum and hello everyone. We are Group 15 presenting our project for JFT10703 statistic for technologies. Our project is titled Energy Consumption Analysis, a hypothesis testing study on whether renewable energy reduce monthly electricity consumption compared to non-renewable source. I am Muhammad Adil Solihin, representing my team, Afif Hakimi, Khairuddin and Zamani. Let us begin. Energy consumption is a critical global issue. With rising demand and environmental concern, traditional non-renewable sources like coal and natural gas are linked to higher consumption and environmental damage. Renewable alternatives such as solar and wind are promoted as cleaner and more efficient, but does switching to a renewable energy actually result in lower electricity usage? There is the question our study investigates. Next is our study objective. Our study has three objectives. First, the primary objective, to test whether the renewable energy adoption significantly reduce average monthly electricity consumption. Second, the statistical objective, to apply an independent sample t-test using SPSS. Third, the analytical objective, to interpret the result and provide the data-driven conclusion based on our dataset. Next slide is our dataset. We were given a dataset of 20 households, starting from H01 to H20, split into two equation groups. The non-renewable group of 10 households have mean consumption of 435.0 kWh per month. The renewable group of 10 households has mean of 340.5 kWh per month. This data has entered into our SPSS for our hypothesis testing, which we will walk through now. So here is our step-by-step for testing our hypothesis. Step 1 is to state the hypothesis. Our null hypothesis, H0, there is no significant difference in average monthly electricity consumption between renewable and non-renewable households. Our alternative hypothesis, H1, renewable energy households have lower average monthly consumption than non-renewable households. This is one-tailored test. We set our significant level alpha at 0.05, meaning we accept a 5% change of error. Next step is to identify statistical distribution and degrees of freedom. Since we are comparing mean of two independent groups, renewable versus non-renewable, and we do not know the population standard deviation, the appropriate test is the independent sample, t-test, which follow the t-distribution. The degrees of freedom is calculated as N1 plus N2 minus 2. We have 10 households in each group, so DF equal 10 plus 10 minus 2. The critical t-value at DF equal 18, with alpha equation of 0.05 for one-tailored test is 1.734. If our calculated t-static exceeds this value, we will reject the null hypothesis. Now, I will walk through how we set up and run analysis in SPSS. In variable view, we created two variables, energy source code 1 for non-renewable and 2 for renewable, and consumption for monthly kWh value. In data view, we enter all 20 rows of data as given in the dataset. Now, we go to how to run the t-test. First, we click the analysis on the top bar, and then we click the compare mean, and then we click independent sample t-test. We can see in the slide. Next, we place consumption in the test variable box and energy source in the grouping variable box. We define group 1 as 1 and group 2 as 2, then click OK. SPSS then will produce two output tables. The group statistic table confirm non-renewable mean equal 435.0 kWh and ST equal 30.28. Meanwhile, renewable mean equal 340.5 kWh and SD equal 90.07. So, from the independent sample test table, we first check levelness test. If its significance is above 0.05, we read the equivalent assumed row. Our result, t statistic equal 8.352, df equal 18, and the p-value SIG two-tailed equal 0.00. For one-tailed test, we divided the p-value by 2, still 0.000, which is far below our alpha of 0.05. Therefore, we reject the null hypothesis.
This means there is strong statistical evidence that households using renewable energy consume significantly less electricity compared to households using non-renewable energy. In addition, the statistical value of 8.352 is much higher than the critical t-value of 1.734, which further strengthens our conclusion. This indicates that the difference between two groups not caused by random variation but is statistically meaningful. Overall, the SPSS analysis clearly shows that renewable energy adoption contributes to lower monthly electricity consumption.
In conclusion, renewable energy households consume an average of 340.5 kWh, 94.5 kW less than non-renewable group at 435.0 kWh. With a p-value below 0.05, this difference statistically significant. We reject H0 and conclude that renewable energy adoption does significantly reduce monthly electricity consumption. This supports the global movement towards sustainable energy as more efficient alternative. Thank you for watching. This has been Group 15. Assalamualaikum.